Welcome to another episode on my driving robot discovery based on the fischertechnik TXT controller running embedded Linux. Last time I found out that the use of OpenCV as intended for course correction is actually not working quite well. That is not because OpenCV doesn't work well, because the imaging mostly works. The reason is that imaging needs to be much more frequent. Right now the imaging starts when it starts to drive, and the next image is when it hits the objects. So that are those number of frequencies. That number of frequencies are way too few. It needs to be much more like in 10 seconds or in centimeters. Now, if you're talking about distance, you have to apply a technique called odometry, which measures distances. That can be applied using the pulse counts from the motors. If you have a number of pulses from the motors, you can say, okay, after so many pulses take an image, or you can time it. And both are going to be a bit problematic, because it drives in a curve, and that means that the motors are not equal. They are controlled equally but not doing equal. And timing is, well, how fast does it drive anyway? Anyway, let's see how it does do right now. Camera connected. There we go. Okay, this is not as supposed to be. And let's interrupt it. A clear diversion, and if I take a look at the images that are being taken, 2 images and actually 3 images, but one is the normal image, the second is the gray image, and the other one is another gray image. So I have one usable image, which is 11K. But as you can see, it moves from here to there, only producing one image, and that's what I said. How do you do that when it not only takes one image but also in a curve? So I have to apply to adjust the algorithm for that. That's going to be a challenge. So let's have a look on how that can be applied.
Alright, so things do go wrong. There are a few thoughts to be considered. One thought is what is going on exactly. Well, one thing is certain, it drives quite fast. And it makes only one usable image. Apart from that, it drives in a curve away from its planned trajectory, which is just a line straight on. Then what really happens is that apart from the interrupt that I gave, Ctrl C, is that it does do the contact 1 is 1. Well, given the fact that it goes that way, it works, and that's I'm not using overflow right now, but anyway, one of these is 1 and it checks. So how does the algorithm do? I have a couple of conditions. One condition, context 1, which is this one. Then it has another condition, contact 2, this one, and so forth. Another one for both. Yet another one, sonar. Yet another one, sonar, and so on. It takes time to go by all these conditions. That's fine, but during that time it also drives on. So now I do know it's not slow, not at all. Can I get the CPU speed out of this? It's Linux, so how fast can it go? Well, ARM-v7, that's not of my interest right now. Alright, that is too much. No, this is, here I should see. OMAP, clock event, that's interesting. OMAP, no longer in development. 2 gigahertz. But the base is it? Megahertz, 20 megahertz. Could be. Anyway, it's pretty fast. So I can think, I think I can safely assume that the whole algorithm is taken care of in this short period of time. Then if so, why does it only take one image during this drive? So I have to assume there is a shortage of time before starting and ending, because it what you noticed in the first segment is that although it says here contact 1 is 1, motor stop, that it doesn't stop before it completely drives against this object, which is pretty large, quite too heavy, heavier than this one is. So regardless of what happens, something is slowing down the usable images. So what to do about that? That is a very good question. Speed things up? Possibly. Well, this is certainly 1/100th of a second and very, very short. some thoughts to think about, to consider how to change an algorithm. Interesting. Okay, another thing that I just noticed is the distance. Here it says starting distance is 21 centimeters, which means that when it started right here, it measured a distance of 21 centimeters till some object. Here it measures a distance of 5 centimeters, CAS. So where is CAS? Since we are talking about contact 1, I should look for something called CAS here. And where is that? In camera action algorithm. And where is CA0? It's in the very first. It's not even in the first contact, in the first condition. It's just right here. So in between camera action 0, doing the whole algorithm and printing the distance, which is measured from here and from nowhere else, it has already covered 16 centimeters. It doesn't have time for anything else. So, in order to check that, I need a much larger distance. And then the problem comes, well, it goes now pretty fast speed, so how do I do that? Here it starts at 256. And then I go down and down and down. Although here I don't set the speed actually, I just say stop. Here also stop. And here I set a distance to be covered. If it doesn't do anything. So I think it is best if I change the initial speed, giving it some time. What about cutting it in half, making it no. Oops, that is not right. So, making it 125. Right here. And here doing the same, 125. Why isn't it working correctly? Right. Whatever. And now I can check if changing this speed actually gives it more time to do anything at all. And of course I have to reposition the robot. So with this set, let's do things.
So with half the speed, let's see how things go. If things work. Error in camera thread. I don't like that. Attempt 2. Connected. Okay. This is something completely different. Nice and slow. And does it touch? What does it do? Contact 1, speed 0. Alright. Premature end of JPEG file by sending lamp on, etc. End. So yeah, then it should have now time to send nice messages, nice images. Let me check if it is indeed what I expect to be. Starting with the oldest. That's pretty far away. And then next one. Is even further away. So, but there are now more images available, and that is good. So now up to the next test. But what I wonder is if it pushes it away. So I don't know if that is nice or not. Let me turn it and do it again. Does it do a nice straight line again? Camera connected. There we go. Well, that is a hit, clearly. But it doesn't stop. Well, not until now anyway. It keeps on going. Taking images. Distance of sonar is 5. 5. And it keeps on going. Okay, time to stop and do it again. This is remarkable. It should stop, but it doesn't. So let's put it here, or even further away. Do it again. Network error, so I have to do it again. Once more. And it does do imaging. Now it starts arriving. Oh, that is not what I anticipated. Let's do it again. From here. Error in camera thread. Okay, let's see some images.
So, where have we gone? Well, clearly half speed. Still in this position. These are two images that I have watched now. This is clearly on a further distance than this one. So let's see some more. And I am diving into this one. Now, this is the timing. And let's see. Camera 0 on that point. Which camera does what? I don't have it. 11 should be a sequence number. Is 15 a sequence number? I think I can get, unfortunately. Camera action 13. So these are seconds. Okay. Let's change this. 40. No. Wait a second. This is not. Why is this on January? No, I have to look here. I didn't do a clear screen after removing all these. So I have to look here again. 46 would be a nice one. And that is close to the next object. The big object, which is behind these things. So after pushing this one away, or either one, it stops and has this one. How much time between them? 22 seconds. And this is a 0. This is also a 0. So these images are taken at not even during either contact or sonar. This one is. So let's see what this one does. This is 43.56. Also. Oh, yeah, that is about the same one. 46.0. And 56. Yeah. 50. Oh, that is 10. Yes. So 56.10. Is it? It is. But this is a different one. This is 46 and this is 56. So near 10 seconds later. So it stopped for 10 seconds, held back for something, and it made an image. How many images are there? Oops. Touch it on. TXT image. And look here. The very last one is 0. And that is, it stopped here for some reason, and the last image was made 0. Why? I don't know. But still there must be a way to go, because in here it is clearly a distance, not as fast as should be, so I am now certain that it should drive slower. That's one thing that is for sure. Although I hate these errors, and when the error in camera thread comes, I don't know, imaging, why this happens, not clue. I didn't write the software. Where to go from here?
Last part of this episode and video, so let's see how it keeps behaving. Does it? Alright, it starts and it has immediately a diversion of the trajectory. It doesn't touch the object, it just signals something, which is probably due to the sonar, and it stops. Sonar is 4, so now it actually uses the sonar, which is very nice. Let's repeat this. I hope. Right, good stuff. Remarkable that it starts with a diversion of the trajectory. And this was distance of 2 now. Does it stop? Letting it go. It doesn't stop. Nope. Yeah, it does. But after a much longer time. Alright, final attempt. Does it keep behaving like this? Let's see. Taking an image. And now it will miss with the sonar, I think. Although not necessarily, since it now it touches, but barely touches. And now it goes for the sonar, I think, of the no. Lamp on. I didn't see lamp on. It completely missed the actual object and it stops. Alright, much to think about. In any way, a more pleasant result, but we're not there yet. Thank you for watching. If you like this video, please subscribe to my channel. Give the video a thumbs up and leave a comment. You can also follow me on Twitter. If so, then retweet and like, leave a comment. On Instagram, like and leave a comment. Much appreciated. I always answer or respond. Please donate to keep videos coming to you. More information on my website. You can also become a patron and have your name mentioned depending on the pledge you make, either on just on my website or on my website and with the video. Much appreciated. And this is going to be continued. Once again, thank you for watching.